Alright, free response time. We've done these in class. Let's go over it again though. This first one, single replacement reactions. Magnesium ribbon, Mg0, is dropped in a solution. There's our water word. Silver nitrate. Mg is going to go up to Mg2 plus. Ag is going to go down to Ag0, and I have Mg2 plus Ag0. Awesome. If you do want to balance for charge, you're going to end up with that. Oxidation of magnesium before is 0. Magnesium after is 2 plus. It's the reducing agent. It's oxidized. Chlorine gas is bubbled into a solution. Sodium bromide. Chlorine's going down. Bromine's going up. Don't forget, if you start with a Twinkie, you end with a Twinkie. So we got Cl minus plus Br2, 0. 2. Great job. The reducing agent is the one who's oxidized, and there's my up arrow, Br minus. Zinc metal is placed into a solution of copper 2 chloride, Zn0. Cu2 plus, Cl minus. Solution, there's our water word. Metals are going to go up. Zn is going to go up to our 2 plus. Cu is going to go down. Zn2 plus Cu0. There's our answer. We're going to calculate the E cell, and we're going to end up with 1.10 volts. For this, I'm going to say C, multiple choice, number 30. And it's spontaneous. If E is greater than 0, delta G is going to be less than 0. Remember, the equation is delta G is negative NFE. Alright, next one. Means it's in water. Pb2 plus NO3 minus plus K plus I minus. All we got is ions. Alkali nitrates are going to cancel. There's our solid precipitate. We'll put a 2 there. Spectators are the ooh ah. Hello, Mr. Spectators, alkali nitrate. Dilute hydrochloric acid reacts with a solution of sodium carbonate. I see nothing but ions, so I'm going to swap. I'm going to cancel the alkali. There's my stick. H plus plus CO3 2 minus makes H2O plus CO2 2. We know that this one is the gas because it's got London intermolecular forces, no hydrogen bonding, and the Lewis structure for that is going to turn out to be that. It's sp hybridized at the central atom. It's linear. And there's 2 sigmas and 2 pi bonds. This one we don't have to do because I did it again. Okay, sodium metals dropped in water. There's your key word. Na0, H2O, boom! Na plus, 2OH minus plus H2, boom, there it is. We know that this isn't going to make phenolphthalein turn pink. So phenolphthalein indicator in the presence of hydroxide is going to go from clear to pink in presence of OH minus. Okay, solid potassium chlorate is heated. There's my solid potassium chlorate. Heated is not burned. Heated is a decomposition word. That's a liquid. That's oxygen. I didn't note that that's a liquid, but I just know. So you don't have to put that. Okay, entropy value. Well, this goes from a solid, liquid plus gas, and even if you didn't know that, it goes from a solid to a gas, so it gets messy. So delta S is positive for this reaction. It doesn't ask you to explain, so we're not going to explain. I hate it when this happens. Alright, propane gas is burned in air. C3H8 plus O2, CO2 plus H2O, CH, then O. 3 C's, 3. 8 H's, 4. O's, 6 there, 4 there, 10, 5. The word burn tells us that it's an exothermic reaction. Gosh! Sorry. What's going on, Kels? I'm sorry, everybody out there in internet ether land, out there on the information superhighway. Alright, here I am. Delta H is negative. It's burn. Picture, there's the picture. I got it. Well, I trained you guys to do something every time you see this. We are going to draw out anode-cathode flow of electrons. If we look on a standard reduction potential chart, AG is up there and ZN is up there. So we know that the highest one is the cathode and the lowest one is the anode. So electrons go from anode to cathode. So that makes this, yes, the cathode. That makes this the anode. There is our flow of electrons. Hi, Albert, Nicole. So we labeled it. We did direction of electron flow. Okay, this is where people have been screwing up. So the half reaction that occurs at the anode, this has to be an oxidation reaction. So at the anode, it's going to be Zn going to Zn2 plus 2 electrons. And at the cathode, this is going to be a reduction reaction. So you're going to have Ag plus 1 electron going to Ag0. Now the common multiple between 2 and 1 is 2, so you're going to be multiplying this by 2 and this by 1. So when we write the overall net reaction, the left side, we're going to write everything that's on the left. So these are our chemicals on the left side of the arrow. And on the right side, we're going to write everything that's on the right. Those are our chemicals. The electrons are going to cancel out. So we're going to be left with Zn0 plus 2 Ag plus goes to Zn2 plus 2 Ag0. They want us to calculate the E cell. So that's negative Eox plus E reduced. And the one who's oxidized is Zn, and the one who's reduced is Ag. So that's going to be... Ooh, I never did this problem on your key. Sorry. So here we go. That's going to be negative 0.76 volts. And Ag. Someone out there has got a reduction potential chart somewhere. Reduction potential chart. Save me. Here it is. So Zn is that. What's Ag? 0.80. So 0.76 plus 0.80 is going to be, good job there, Riley. Okay, so we're going to calculate delta G for this reaction. Delta G equals negative NFE. We know that N is 2, because that was the moles of electrons transferred. We know that Faraday's constant is that, and we know that E is 1.56, and it's going to be something joules. Okay, and you can divide by 1,000 to convert that to kilojoules. Oh, I did my thing again that I do that annoys me. So I'm going to stop here and finish it off on the next one.